In this lesson, we're going to solve problems involving geometric sequence and series. Problem number 1. Certain microorganism doubles every 2 hours. If initially 280 bacteria of this kind are in the laboratory, find the number of bacteria after 10 hours and how long will the number of bacteria become 17,920. So, dito sa problem na to, meron tayong microorganism and then nagdo-double yung number niya every 2 hours. Initially or at the start, meron tayong 280 bacteria sa laboratory. So we need to find the number of bacteria after 10 hours. And hanapin natin kung ilang oras magiging 17,920 ang bilang ng bacteria sa loob ng laboratory. So, let's have the given. Yung given natin, ang first term is 280. Ang common ratio ay 2 dahil nagdo-double siya every 2 hours. And then, yung n natin ay 5. Bakit 5? Hindi 10. Kasi, every 2 hours lang siya nagdo-double. So, ibig sabihin, i-divide lang natin yung 10 sa 2. Kaya magiging 5. So, ibig sabihin, 5 times lang siya magdo-double ng numbers. Then, to solve for the number of bacteria after 10 hours, kailangan natin gamitin yung end term. So, yung end term natin na a sub n is equal to a sub 1 times r raised to n minus 1 dahil ang ating sequence ay geometric dahil dun sa word na dumudoble. So, nagmumultiply yung ating sequence. So, substitute lang tayo. We need to find the a sub 5. A sub 1 is 280. Common ratio ay 2, and then yung n natin is 5. Then simplify, 5 minus 1, that is equal to 4. Then 2 raised to 4, that is equal to 16, and 16 times 280 equals 4,480. So it means 4,480 bacteria after 10 hours yung makikita natin sa loob ng laboratory. Next, let's have the second problem, number of hours when the bacteria becomes 17,920. So, yung additional given natin is a sub n equals 17,920. So, ilang oras magiging ganito karami yung bacteria sa loob ng laboratory. So, gamitin ulit natin yung nth term pero this time, n naman ang isosolve natin. So, substitute tayo ng a sub n which is 17,920 at yung a sub 1 pa rin natin na 280 at ang r natin na 2. And then, simplify. Kailangan matanggal natin itong 280. So, magde-divide both sides tayo by 280. So, makakancel na dito. Magiging 1 na yung 280 over 280. Then, dito naman, madi-divide yung 17,920 sa 280. That is equal to 64. And then, matitira na lang yung 2 raised to n minus 1. And then, kailangan natin gawing base 2 yung 64. So, para magawa yun, kailangan natin alamin kung ilang 2 ang imumultiply sa sarili niya para makuha natin ang 64. So, kung gagawin mo yun, that will be equal to 6. So, pag minultiply mo yung 2 ng 6 times sa sarili niya, ang magiging sagot ay 64. And since parehas na sila ng bases, pwede na natin makakuha tayo ng bagong equation na 6 is equal to n minus 1, then solve for n. So, transpose lang natin yung negative 1 sa tabi ng 6, magiging positive 1. It means ang value ng n natin ay 7. So, 7 times na magdodoble yung bacteria para ma-reach niya yung 17,920. At dahil every 2 hours siya nagdo-double, ita-times natin yung 7 sa 2. It means after 14 hours, the bacteria become 17,920. Let's have our second example. In 2013, the number of students in a small school is 300. It is estimated that the students' population will increase by 4% each year. Estimate the population in 2024. So, yung solution natin, ang given natin, a sub 1 is 300 because this is the initial population. And then, ang common ratio ay 1.04. So, from 300, this is considered as 100%. So, the other year, magdadagdag siya ng 4%. So, magiging 104%. And 104%, i-convert siya sa decimal, magiging 1.04. Mag-move lang siya ng 2 decimal places to the left. And then we have n is equal to 12 kasi 2024 minus 2013 ay 12, including natin yung 13. So, parang nag-plus 1 pa lang. And then, to solve for the total population in 2024, gagamitin natin yung nth term na a sub n is equal to a sub 1 times r raised to n minus 1. Then, substitute tayo. We have a sub 1 is 300, yung 1.04 na common ratio, and then yung 12 na value ng n. Then 12 minus 1 is 11, and 1.04 raised to 11 is 1.54. 1.54 times 300, that is 462. So it means we have 462 students in the year 2024. That is the estimated population in the year of 2024. Let's have our third problem. In a game, each player has to relay the same message to 2 persons in a minute. Starting off with the first player, how many persons receive the same message in the 10th minute, and how long will the message be passed on to all other 254 individuals? So, before answering the problem, let's have first our given. Ang a sub 1 natin is 2, ang common ratio natin is 2, at ang n natin ay 10. Doon sa unang problem. Hindi natin gagamitin yung 1 as our a sub 1 kasi this is our initial player. So, kailangan muna niyang i-relay yung message sa 2 persons para makapag-start tayo ng ating game. So, ang ating a sub 1 ay 2. Kapag na-relay na niya sa 2 persons yung kanyang message. And then, yung message dapat ma-relay in a minute. So, kailangan natin malaman kung ilang tao na ang naka-receive ng the same message after 10 minutes. So, let's solve the problem using nth term of the geometric sequence. That is a sub n equals a sub 1 times r raised to n minus 1. Substitute tayo ng a sub 1 which is equal to 2. Ang r natin is also 2. And then, ang n natin is 10. Then simplify, 10 minus 1 is 9. And 2 raised to 9, that is equal to 512. And then 512 times 2, that is 1024. So it means after 10 minutes, we have 1024 persons would receive the same message. Then next yung ating second question, how many minutes will the message be passed on to 254 individuals? So, mayroon tayong next na given na S sub n is equal to 254 dahil ito yung sum ng persons na naka-receive na ng message. So, pero kailangan nating alamin kung ilang minutes na or ilang minutes ang makakaraan bago siya ma-receive ng 254 individuals. So, since S sub n ang given natin, ang gagamitin nating formula is yung S sub n ng ating finite geometric series. So, substitute lang tayo ng a sub 1 which is equal to 2, tapos yung common ratio natin ng 2, and then ang ating S sub n na 254. So, simplify muna natin yung 1 minus 2 that is equal to negative 1. And then next, multiply both sides by negative 1. So, matatanggal na yung negative dito. Nagiging positive na. And then, yung ating 254 magiging negative. Yung next naman is, kailangan ma-remove natin yung 2. So, magdi-divide both sides tayo by 2 para ma-cancel yung 2 dito sa right side. And then, ma-divide yung negative 254 by 2. So, that will be equal to negative 127. Then, dito magiging 1 na yung ating 2 over 2. Then, next, kailangan natin ma-isolate yung 2 raised to n. So, transpose natin yung 1 sa left side, magiging negative 1 na siya. And then, negative 127 minus 1, that is equal to negative 128. And then, kailangan matanggal natin yung negative dito sa 2 raised to n. So, multiply both sides by negative. Magiging positive na sila pareho. Then, to solve for n, kailangan natin gawing base 2 yung 128. So, again, maghahanap ulit tayo ng number or kung ilang number ang pwedeng i-multiply sa 2 para ma-solve natin yung 128. So, pag ginawa mo yon, that is equal to 7. So, 7 times natin, kailangan i-multiply yung 2 sa sarili niya para ma-solve natin ang 128. So, may bago na tayo ulit equation na 2 raised to 7 equals 2 raised to n. And then, since parehas na sila ng base, pwede na natin i-conclude na equal yung kanilang exponent. So, it means we have now 7 is equal to n. So, ang n natin ay 7. It means, after 7 minutes, makaka-receive na ang 254 individuals ng same message from the relay. Proceed tayo sa fourth problem. Suppose that there are 123 asymptomatic individuals that were tested positive last June 9. How many individuals will possibly be infected on June 21 if the transmission rate remains at 1.2? And how do we find out the projected total new COVID-19 cases from June 9 up to June 21? So, to answer the first problem, let's have first our given. Ang A sa buwan natin ay 123, ang common ratio ay 1.2, ang n natin is 13. Kasi 21 minus 9, that is equal to 12 plus 1 is equal to 13. Kailangan mag plus 1 para ma-include natin yung June 9 sa ating counting. Then, to solve for the infected on June 21, we need to use the n term for geometric sequence. We have a sub n equals a sub 1 times r raised to n minus 1. Then, substitute lang tayo ng a sub 1 na 123. And then, yung common ratio natin na 1.2 dahil yung kanyang rate ng transmission ay 1.2. And then, yung n natin na 13. Then, simplify 13 minus 1, that is equal to 12. Then, 1.2 raised to 12, that is equal to 8.92. And 8.92 times 123, that is equal to 1,097 approximately. So, ibig sabihin, 1,097 were possibly infected on June 21. Then, letter B problem, how do we find out the projected total new COVID-19 cases from June 9 up to June 21? So, yung solution natin, first is yung given again is 123. Ang rate of transmission ay 1.2. And then, ang n natin ay 13. So, kailangan natin malaman yung total number of projected cases. So, we need to use the S sub n ng ating geometric series o yung ating finite geometric series na S sub n equals a sub 1 times 1 minus r raised to n all over 1 minus r. Then, substitute tayo ng given. A sub 1 is 123. Yung r natin ay 1.2 at yung n natin na 13. Then, simplify muna tayo. 1 minus 1.2 is equal to negative 0.2. And then, 1.2 raised to 13, that is 10.7. Then, 1 minus 10.7, that is negative 9.7. Then, next, multiply tayo. 123 times negative 9.7, that is equal to negative 1,193.1. Then, divide natin siya sa negative 0.2, that is equal to positive 5,965.5. Or approximately, meron tayong 5,965 individuals that are possibly infected from June 9 to June 21. That is the total possible individual. Proceed tayo sa fifth problem. A ping pong ball is dropped from a height of 72 inches. After the ball hits the floor, it rebounds to 80% of the previous height. So, ibig sabihin, yung isang bola daw ng ping pong ball ay ibabagsak from the height of 72 inches. So, ito yung height na 72 inches. Tapos, ibabagsak siya sa floor and then magba-bounce back. Pag nag-bounce back, itong second height o yung height 1 na niya ay 80% ng kanyang previous height. Ito yung kanyang initial height na 72 inches. And then, yung next na height niya is another 80% na nung first height niya. So, kung i-analyze natin, dalawa yung magiging height. Isang height kapag bumabagsak yung bola at saka height ulit kapag ka nagba-bounce back na siya or nagre-rebounce up na siya. So, dalawa yung height natin. May height tayo na pabagsak at may height tayo na pataas. So, from that, we need to find how high will the ball rebound after being dropped. So, kung i-analyze natin yung pagbagsak ng bola, ito yung kanyang initial height from 72 inches. Ibabagsak mo siya pababa sa floor. Pagbaba sa floor, magba-bounce back siya. So, kailangan natin mahanap yung first height niya pagkatapos niyang bumagsak sa lupa. So, that is 80% nung kanyang previous height, which is 72%. So, ibig sabihin, i-convert mo lang yung 80% sa decimal, magiging 0.08. Or, kailangan mo lang i-move tong 80% ng 2 decimal places pa kaliwa, so magiging 0.80 na siya. So, 72 times 0.80, that is equal to 57.6 inches. Yan yung kanyang pangalawang height or yung kanyang unang height pagkatapos niya bumagsak sa lupa. Yung next question is, how many inches will it travel before coming to rest? So, yung tinatanong is yung bola. So, kung ilang inches yung na-travel niya bago siya mag-stop sa pag-bounce. So, una, yung pinaka-solution natin, yung problem natin consists of two infinite geometric sequence. Kasi yung pag-dribble ng bola. So, hindi natin malalaman kung ilang beses lang siya pwedeng tumalbog. Kaya, magiging infinite siya. So, yung una is yung first sequence natin is yung ball falls. So, pagbagsak sa lupa, start with the initial height na 72 inches. Ito yung unang sequence na kailangan natin isolve. Ito yung mga height niya. So, starting from the initial height na 72 inches, tapos sunod yung pangalawang height, pagbagsak niya ulit, another height ulit, and another height. So, ito yung unang sequence na kailangan natin isolve. Yung isa pang sequence ay yung kanyang pag-rebound. So, yung pagbalik naman ng bola. So, yun yung isosolve natin mamaya. Solve muna natin to from the initial height na 72 using the infinite geometric series na a sub 1 over 1 minus r. So, substitute tayo yung a sub 1 natin na initial height which is 72. Tapos, yung common ratio na 0.8. So, 1 minus 0.8, that is 0.2. Then, 72 divided by 0.2, that is 360. So, from the height, kung yung pagbagsak ng bola, ang magiging total height na makukuha natin or yung matatravel ng bola ay 360. Yung next naman ay kailangan natin isolve yung total height niya sa pag-rebound from 57.6 kasi ito na yung height niya, yung starting height niya kapag nagre-rebound na siya. So, parang ito na siya. Ito na yung unang height niya, pangalawang height, pangatlong height, and so on. So, kailangan nating hanapin yung sum nung height na yon or yung height na tinatravel nung bola. So, using infinite geometric series pa rin, we have a sub 1 over 1 minus r. Substitute tayo ng a sub 1 na niya, yung 57.6. Tapos 1 minus 0.8, that is 0.2. Then 57.6 divided by 0.2 ay 288. So, from sa first solution natin kanina na 360 starting from the initial height na 72, i-add natin ngayon yung kanyang total height dun sa kanyang pag-rebound na 288. So, pag in-add mo yan, that is equal to 648. So, it means yung ping-pong ball ay magta-travel ng 648 inches hanggang sa siya ay tumigil sa pagtalbog. Let's have our sixth example. A pendulum is released to swing freely on the first swing. It travels a distance of 30 cm. On each successive swing, it travels 60% of its previous height. So, ito yung ating example ng pendulum. Nagsuswing siya. And then, we need to find the distance of the pendulum on its second swing and on the third. So, dahil 60% na lang nung kanyang previous swing, yung magiging susunod na swing ay kailangan natin i-multiply yung 30 sa 0.6 kasi 60% pag kinonvert sa decimal, that is 0.6. And 30 times 0.6, that is 18. So, ibig sabihin, 18 centimeter yung kanyang second swing. Tapos, yung third swing, from 18, ita-times ulit natin siya sa 0.6, that is 10.8 centimeter. Yan yung kanyang third swing. Yung next question is, what is the total distance traveled by the pendulum? Yung pendulum natin, hindi natin malalaman yan kung kailan siya titigil. So, ibig sabihin, pag pendulum, gagamit tayo ng infinite geometric series dahil kailangan natin kunin yung total distance traveled by the pendulum. So, with the use of S infinity is equal to A sub 1 over 1 minus R, substitute tayo ng A sub 1 natin, which is equal to 30. And then, yung common ratio natin na 0.6. So, 1 minus 0.6, that is 0.4. Then, 30 divided by 0.4 is equal to 75 centimeter. So, all in all, ang magiging distance traveled by the pendulum is equal to 75 centimeter hanggang sa siya ay tumigil.